In this problem, we have a fixture that has a spring attached to one end that does not move, and the other end is attached to a mechanism that slides back and forth. We want to find the formula for the force of the spring at a given z displacement from the origin, and the forces in the x and y direction. We'll also be solving with the value for the z dimension of 0.5 meters. So we will be using the Pythagorean theorem and Hooke's law, or the spring formula, to complete our calculations. How do we go about solving this one? So first, we must visualize a right triangle. Doing so, we have a leg that is the initial spring length and a leg that is the z displacement. And we want to solve for the spring's current length, which is the hypotenuse of this right triangle. So we can rearrange the Pythagorean theorem to be the square root of a squared plus b squared equals c. So really, the square root of z squared plus the initial side length squared equals the current spring length. Next, we'll be using Hooke's law, or the spring formula, which is the k, or spring constant, times the x, or displacement. The displacement being the amount of change in length of the spring, not the z displacement in this formula. So the displacement is really the current spring length minus the initial spring length. Plugging in our values, we are left with the spring displacement of the square root of z squared plus 1.35 squared parentheses minus 1.35 meters. Now we can plug those values into the spring formula, Hooke's law. This leaves us with the formula to determine the force the spring is exerting. Plugging in our 0.5 meter arbitrary example displacement, we are left with a force of the spring of 67.2 newtons. Now to find the force in the z direction, we can use the property of similar triangles, basically because the force vectors triangle is proportional to the side lengths of the displacement triangle. They have the same ratios, also they have the same angles. To find the force in the z direction, we take the force of the spring times the ratio of the z displacement, which is 0.5, over the current spring length. Plugging our values in, we get 23.3 newtons for the force in the z direction. To find the force in the y direction, we do the same thing, but with the force of the spring times the ratio of the initial spring length over the current spring length. Plugging in our values, we get a force in the y direction of 63 newtons. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching.